Amaya, Amaya, Atulya,
Present, Miss.
Rishya,
Present, Miss.
Jyotish, Karthik, Kavya,
Present, Miss.
Nachiket, Neeraj, Neerajana,
Present, Miss.
Rangeet, Vaishna, Vaishnav, Anjali,
Present, ma'am.
Shruti. Latecomers Afla C and Amaya,
Present, ma'am.
Jyotish,
Present, Miss.
Present, Miss.
Nachiket,
Jengida, ഞാൻ വിചാരിച്ച് എന്നെ വിളിച്ച്. Present, present.
Nachiket, Rangeet. Okay, Vaishna and Vaishnav. No. Okay, we'll start. Okay, in the morning class, we were discussing about the categories of flow control mechanism. Okay, we were dealing with the categories of flow control mechanism. Flow control means they are the set of procedures that informs the sender that how much frame it has to send before waiting for an acknowledgement. You can have two different types of protocols here. One is called it as the stop and wait protocol, and the another one is called it as the sliding window protocol. And in the morning, we have just seen what is stop and wait protocol. Stop and wait. The meaning is you can send one frame at a time. Okay, that is the sender is transmitting the data. It transmits one frame. It waits for an acknowledgement. Until and unless it is not receiving the acknowledgement, the next data frame is not transmitted. So some waiting time is there. So that makes the transmission very, very slow in case of stop and wait protocol. Okay, but the advantage is, what is the advantage? It is error free and bit by bit only, I mean data by data only, it will be transmitting. Okay, now we will see the second type of flow control mechanism, that is called it as the sliding window protocol. Sliding window protocol. Sliding window means you are sending several frames at a time. That is, multiple frames can be sent at a time. Now, how does this work? So, sliding window, here the sender can transmit multiple frames. Those frames in its window. The meaning is you have got a window and whatever frames are there in that window, they can transmit that data. Okay. It should not wait for the acknowledgement for the each data, whatever it is sending from the sender side. Maybe bulk wise. So one acknowledgement means it may be the acknowledgement of multiple datas. Okay. Now what happens at the receiver side? Receiver side, it accepts and holds the multiple frames. They are also having a window and they will also accept and hold the multiple frames. And they will be sending the acknowledgement. Whenever it is feeling like sending the acknowledgement, they will send it. Okay. And they have to send the acknowledgement once the window is full. The meaning, as I'll just explain once again. So sliding window method, the transmitter, the sender can transmit several frames at a time before waiting for an acknowledgement. The meaning is the link can carry several frames at once. That means the maximum capacity is used efficiently in case of sliding window. Okay, and the receiver, it won't be acknowledging all the frames, it will be acknowledging only some of the frames. The meaning is, if a single acknowledgement is sent, maybe it will be the confirmation of the multiple reception of data frames. Okay, now here you are having an imaginary window that you can see in the diagram. What does that window means? Means those frames within the window are able to transmit at a particular time. And the size of the window means how much frames it covers. Here it is 1, 2, 3, 4, 5, 6, 7, 8, 9. The window size is 9 here. Okay, so sliding window protocol, here in this type of transmission mechanism, you are defining an imaginary window both at the sender side and as well as the receiver side. And this window, it consists of maximum n frames at both the sender and the receiver. Okay, the meaning is those frames within the window are transmitted at a time. I hope you can hear it. Okay, so those frames which are inside the window are able to transmit at a particular time. The meaning is the window defines how much data the sender can send before it must wait for an acknowledgement. Now the receiver acknowledges only some of the frames using a single acknowledgement to confirm the receipt of multiple data frames. That is what I told in the before. It won't be acknowledging all the frames it receives. Maybe it is sending the acknowledgement to confirm the receipt of multiple data frames. Okay, now sliding window. Why that name means? See, you can see in this diagram, sliding window means you are seeing a window both at the sender side as well as the receiver side. Now look on to the sender side window. Now some data frames are inside that window. And now why it is called sliding means whenever you are passing a data from the sender side, the wall that is towards the left, it will move towards the right when a frame is sent. The wall that you can see in the diagram, it will be moving towards right when a frame is sent out of the window. Now what happens on the other side? So the wall that is on the right hand side, it moves to the right when an acknowledgement is received. So whenever a data frame is sent from the window, the wall is sliding towards right, and whenever it receives an acknowledgement from the receiver side, again the right hand side of the wall is shifting towards right. Okay, so that is the case that is happening in the sender window. Now what happens at the receiver window? Now look onto the receiver window wall. So the wall that is on the left side of the receiver, that will move towards right when a frame is received. Whenever the receiver is receiving a frame, the wall will move towards right. Okay, now what happens at the right hand side? The wall moves to the right when an acknowledgement is sent. So what is happening in sliding window is the shifting takes place towards right when it receives a data or when it sends a data, and once the acknowledgement is received or once the acknowledgement is sent. Okay, both is happening. The shifting is taking towards right in both the cases. Okay, as an example, now look on to this example. See, this is an example of sliding window. More clearly, you can understand how the sliding window works. So sliding window, you can have a sender and a receiver. You can see a window. Just look onto the sender side now. What is the window size there? Can anybody tell what is the window size there? You are having an imaginary window there. And what is the size of the window? How many frames are being there in the window? 0, 1, 2, 3, 4, 5, and 6. That means 7. The window size is 7. The meaning is in sliding window protocol, the sender can send 7 frames at a time. Sender can send 7 frames at a time. Now, look on to the middle part. What happens when data 0 is sent from the sender side? Once the data goes out of the sender side, now what happens? The window, the wall that is towards the left will shift towards right. So what is the data in, what is the frame inside the window now? It is 1, 2, 3, 4, 5, and 6. It is shifted towards right by 1 unit. Understanding? Are you hearing? Vaishnav?
Yes, miss.
Yes, okay. So the window size is 7 initially. Now what happens when data 0 is gone out of that window? It is slided towards right. Okay. Now at the same time, what happens at the receiver side? Receiver side also, initially the window size was 7. Now once it receives the data, then what happens to the window of the receiver side? That also will be slided towards right or shifted towards right by 1 unit. Because only one data is received now. So it is shifted towards 1. So the frames inside the window at the receiver side is 1, 2, 3, 4, 5, and 6. Okay, now what happens when data 1 is sent from the sender side? Now you can see on the left hand side. Once the data 1 is sent, how does the window slide? The window slide towards right by 1 unit. So what is that frame inside that window now? It is 2, 3, 4, 5, and 6. Okay, now what happens at the receiver side? Once the data is received, again the wall at the receiver side, it is shifted towards right. Understanding? Why it is called it as sliding window. So whenever a data is sent out of the frame, the window is moving towards right, and whenever the data is getting into the frame at the receiver side, again the window is sliding towards right. Now what happens when the acknowledgement is received? So you can see in the diagram here ACK2 it is written. You don't worry about the number now. You just understand ACK is getting at the center side. So when an acknowledgement arrives at the center side, what happens at the center window? The center window, that is the right hand side wall, it will shift towards 2 units. The meaning is acknowledgement 2 means the 2 data has arrived safely and is expecting data 2. That is the meaning of ACK2 there. So ACK2 means it has received the data 0 and 1 and it is expecting data 2. That means 2 data bits have arrived. So the window is slided by 2 units. So you can see when an acknowledgement is received, this window, the sender window is extended towards right by 2 units. So 7 and 0 is included now. Okay, so this is happening. Now you see in the last acknowledgement 6. Acknowledgement 6 means it is expecting data 6. So before that, all the 3 datas were sent. So the window will be slided towards right by 3 units. Okay, now once the acknowledgement, see the receiver side now. Now once the acknowledgement is gone from the receiver, what happens to the window in the receiver side? That is also shifted towards right by 2 units. For ACK2, you can see the window on the receiver side is shifted towards right by 2 units. That is 7 and 0 is included in the receiver side also. Understanding how does the sliding window works? Sliding window means you can send multiple frames at a time. Multiple frames means those are inside the window. sliding window. Means some imaginary path is there, that is called it as the window. So how many frames are there in the window? The sender can transmit that many frames at a single time. Okay, now how does the sliding window works is whenever the data goes out or goes in, the windows will get slided. The wall of the window shifts towards right up to how many data it receives or how many acknowledgement it receives. Okay, so this is the concept. So how does it this is actually the working principle of sliding window. The wall moves towards the right when a frame is sent, and this wall moves towards right when an acknowledgement is received. That is happening in the sender window. Similarly, at the receiver window, the wall is moving towards right when the frame is received, and the wall is moved towards right when an acknowledgement is sent. Okay, understood the concept of sliding window. Now you just understand this. Sliding window means it slides off whenever you are receiving the data or whenever the data is gone out of the window. Okay, understood? What is flow control? Yes or no?
Yes.
Yes. Afla, what did you tell? Yes, okay. So the flow control means you are making some set of procedures to inform. So the sender can send some data. So you are informing that how much data the sender can send before waiting for an acknowledgement. You can have two different categories of flow control. One is stop and wait. Other one is called it as the sliding window. Stop and wait. It is a simple protocol. Means you are transmitting one frame at a time. You will be transmitting one frame. You will wait for an acknowledgement. You will be sending the next data frame. You will be waiting for an acknowledgement. So it is very simple. Now what happens in sliding window is, sliding window, you are having an imaginary window, and whatever frames are there inside the window, you will be able to transmit that. Okay, and acknowledgement is not received. The sender should not think that it should receive the acknowledgement every time. It is not possible. So whenever the receiver wishes to send an acknowledgement, it will send the acknowledgement. But that may be it is for the multiple frames. Okay, this is what we seen in that diagram. Maybe cumulative acknowledgement, it will be sending from the receiver side. So whenever a data is sent from the sender side, the window slides towards right, and whenever it receives an acknowledgement, the wall will again shift it towards right. This is happening at the sender side. Now, receiver side, whenever a data is received, the wall is shifting towards right, and whenever an acknowledgement is gone out, then again the wall is shifting towards right. Okay, so this is the concept of flow control. Now the next one, what you are going to see is the error control. Very, very important, this error control problems. So error control means, is the data link layer is based on automatic repeat request. Automatic repeat request. The meaning is, it is nothing but, see, in flow control mechanism, you are not worrying about the data if it is some error happens, right? What happens if the error, if the acknowledgement frame is lost, or the data frame is lost, or if the frame is damaged? You are not at all worrying about that in the case of flow control. But error control is both error detection and correction. So two things are happening in error control. That is the third function of the data link layer. Okay, so it is both error detection and correction. It allows the receiver. So this type of protocol allows the receiver to inform the sender of any frames if it is lost or damaged, so that a retransmission of those frames is a must. Okay, so how it is being implemented? So that is being implemented by an automatic repeat request. In short form, it is called it as ARQ, automatic repeat request. So whenever any time, whenever an error is detected in an exchange, specified frames are retransmitted, and that process is called automatic repeat request. Understood? What is the difference between flow control and error control? Flow control, they are not at all worried about the retransmission of data. But in error control, it checks the error, detect if there is any error, and also what happens, how you are able to correct it. Okay, so whenever a frame is damaged or lost, the receiver must, this type of protocol, it allows the receiver to inform the sender about the lost frame or the damaged frame. So a retransmission of frames takes place, and that retransmission of frames, you can call it as automatic repeat request. Okay, now here you have got two different protocols, error control protocols. One is already what we have studied in flow control, but an additional extra thing is added, that is nothing but ARQ. Stop and wait ARQ and sliding window ARQ. Sliding window, again, it is of two types, go back N and selective reject or selective repeat. Okay, so error control, here retransmission of data takes place whenever a data frame is lost or damaged. You can have two different types of protocol. One is called it as the stop and wait ARQ, and the other one is the sliding window ARQ. Now, how does this stop and wait ARQ works? Okay, now stop and wait ARQ, it is the first protocol. Okay, error control protocol, it is the simplest protocol also. Now, what is this extra done is you have already studied about the flow stop and wait in flow control. So what is thing is you are adding an ARQ mechanism also in the flow control protocol. Okay, now how this protocol detects and corrects errors? That is what you are going to see. Now, in stop and wait ARQ, what is the first thing is you are making use of sequence numbers to number the frames. If you want to identify the frames, I told retransmission takes place. Retransmission, if you want to retransmit a particular frame, you should be able to identify which frame has got an error. Okay, so the first thing what is required is you should put sequence number in all the frames. Okay, now the second one is the sequence number, it is based on modulo 2 arithmetic. Modulo 2 arithmetic means the arithmetic is done digit by digit on binary numbers. Bit by bit, it is being considered. Okay, now also the third one, acknowledgement is also followed by a number. Now, what does that number means? That number means it indicates the next frame expected. Now, what is the frame I'm expecting as next? So that is the number that is represented in the ACK with acknowledgement frame. Okay. Now, how the retransmission happens is, so in order to do that, what the stop and wait ARQ does is it will keep a copy of the send frame. And whenever they want to retransmit that, they retransmit it. Okay, so that is the working principle of stop and wait ARQ. I told it is it is a mixing of the stop and wait flow control with an additional ARQ mechanism. ARQ means retransmission of data takes place. That is, whenever a frame is lost or damaged, you should be able to send it again. That is the meaning. So that is called it as ARQ. So in order to do that, the first thing is the frame should be numbered. Okay, so sequence numbers should be there to number the frames. The second one, everything it is based on modulo 2 arithmetic. The third one is acknowledgement also will be numbered, and that number represents the next frame expected. Now, in order to do this retransmission, the stop and wait, what it does is it keeps a copy of the frame, what it is being sent. And whenever the receiver is not receiving that particular frame and whenever a request comes from the receiver side, it does the retransmission process. Now, this retransmission can happen in 3 ways. First part is whenever there is a damaged frame. Okay, now second one is whenever you are having a lost data frame. And the third one is whenever you are having a lost acknowledgement frame. These are the 3 possibilities that can happen. So first one is whenever the frame is damaged. Whenever the frame is damaged, what happens? What happens whenever the frame is lost? And what happens whenever the acknowledgement is lost? That is what you're going to see now. Up to now, is it clear? I have told error control mechanisms. Error control, you are having an additional thing that is called it as the retransmission of data, and that is done by a process called ARQ, automatic repeat request. 2 types of protocols you have. One is stop and wait ARQ. The other one is the sliding window ARQ. Stop and wait ARQ. In addition to the flow control, what you have seen, you are adding an ARQ mechanism. Okay, now this ARQ mechanism, in order to do that, you are keeping the copy of the frame, what you have sent. Okay, so whenever, if you want to retransmit, you will retransmit the data. Now, retransmission can happen in 3 ways. Damaged, what happens when the frame is damaged? What happens when the frame is lost? And what happens when the acknowledgement is lost? This much, is it clear for you? Can anybody answer? Is it clear? Yes, okay. So what happens in case of damaged frame? And stop and wait ARQ, what happens when a frame is damaged? Now look onto this diagram. What you can notice in this diagram, you are having a device A, device B, both are connected by a link. At the sender side or from the device A, you are transmitting the data. Data 0 is sent. That is what the first thing, sequence number is put for the data. Data 0 is sent. Now, receiver side, you will get an ACK1. What that ACK1 denotes? I am expecting data frame 1. Okay, so ACK1 means the next data frame expected. So again, the data 1 is sent. You are sending acknowledgement 0, means 0th data is expecting. Now, what happens when a frame is damaged? You can see on the right hand side, once the data 0 is transmitted, there is an error in that frame 0. Now, what the receiver does? In the receiver, it returns an NAK frame, non-acknowledgement frame, and the sender has to retransmit the data. So once it receives an NAK frame, the data, whatever was previously sent, is sent again. Understanding what happens when a damaged frame is found, when the frame is damaged. Okay, so whenever a frame is damaged, it returns an NAK frame, a non-acknowledgement frame. The meaning is the sender has to do the retransmission of the data that is done previously. So it will retransmit the data 0. Okay, so this is happening in the case of damaged frame. Now, what happens in case of lost data frame? You can see in the second diagram, you are having device A and device B. Now, what happens when the data is lost? So, when the data is lost, you are having, see, both the devices, I mean both the sender is actually, it is equipped with a timer. Okay, so once it starts transmitting the data, the timer also starts. Now, if the frame is never making it to the receiver, and when the timer times out, the device A understand that the data has lost during transmission. So once the timeout period is over, the same data is sent towards the receiver. Okay, so it tries to. So if the frame never makes it to the receiver can never acknowledge, right? So once the frame it reaches the receiver only, the receiver can acknowledge the frame or in a positive manner or in a negative manner. Now, what happens if the frame is not reaching the receiver? So a timer is there, a timer starts. So once the timeout period is reached, then the device A understand that, okay, something has happened, so it has to retransmit the data. So it will retransmit the data and it gets back the acknowledgement. So you can see in that diagram, lost, data is lost. What happens? So restart the time and then again it restarts the timer and it waits for the acknowledgement. Okay, so two cases I told, what happens when a data is damaged and what happens when you are having a lost data frame. Okay, now the third one is called the lost acknowledgement frame. What happens when acknowledgement is lost? So once the data is sent from the sender side, the receiver acknowledges that data, but what happens if the acknowledgement is lost during transmission? Again, the acknowledgement, the sender is not knowing whether it is a positive acknowledgement or it is a negative acknowledgement. So what happens is, again, the timer is starting. So within that timeout value, if the negative acknowledgement or a positive acknowledgement, if it is not reaching, the device A understand that something has happened. Okay, so it will wait up to the timeout value, then the same data is transmitted again. Now, once data 0 is transmitted again and once it reaches the receiver finds out whether the data is received in the previous case. So receiver checks the number of new data frames. So if the same old data, if it is received, what happens is the first copy is discarded. Okay, and it will send an acknowledgement stating that it is expecting data, the next data. Here, the ACK1 means it is expecting data 1. Okay, so if it was a negative acknowledgement, what was there? It will accept that data. So two possibilities are there. The acknowledgement can be a positive acknowledgement or can be a negative acknowledgement. So you don't know what the acknowledgement was sent from the receiver side. So if the positive acknowledgement is lost during transmission, then the copy what the receiver receives is discarded. Now, if it is sent a negative acknowledgement, it maintains the copy there. Okay, and it will send back the acknowledgement. Okay, so these are the three cases, the retransmission of data in case of stop and wait ARQ. Lost frame, damaged frame, and lost acknowledgement frame. In three cases, what is happening? Now, what is this type of protocol is inefficient because you have to wait a lot. And receivers, sometimes it will be busy to acknowledge. Sometimes delay can happen in this case. Okay, so here I'm stopping it today. So we have seen what are the things we have seen today. I started with flow control mechanism in the morning class. Flow control, two methods are there. One is called it as the stop and wait. Other one is called the sliding window. Yes, Kavya, you want to tell something? Kavya is there? You want to tell something? No, okay.
No.
Your mic was on, so I thought, okay, you want to tell. Okay. So flow control, two methods, stop and wait and sliding window. Flow, stop and wait, I have told. It will stop, wait, and then it will wait for an acknowledgement, and then it will transmit the next frame. Okay. So sliding window, it can send multiple frames at a time, and you are having an imaginary window, and the window gets slided once the data is gone and once it receives the acknowledgement. Now, the second case, second function or the third function, what we have seen in the data link control is the error control mechanism. Two methods, ARQ, stop and wait ARQ, and sliding window ARQ. ARQ means retransmission of data is done. That is called automatic repeat request. You have seen stop and wait ARQ, three cases, lost frame, damaged frame, and lost acknowledgement. What happens in each cases? Understood this much? Yes or no?
Yes, miss.
Yes, okay. Now, next week, that is the next working day, when my class comes, I will be conducting a quiz. The topics are transmission media and flow control. Okay, transmission media and flow control. Just go through that topics and I'll be conducting a quiz. Maybe it will be objective or some descriptive type also will be there. Okay, don't copy it from the net and write. Few of you people have copied it and written. I will call you individually in this regard. So don't do such things. Whatever you know, you just write it in that answer sheet. So don't try to escape from, so I know everything like that, nothing like that. Whatever concept you understood, you just write it. That I have noticed few have copied from the net and then you have taken the definition and writing it and all. That is not at all. I won't allow that also, and I won't entertain that also. Okay. So afternoon session.